Okay, so now we're going to talk about how to tell the difference if it is inverse or if it is direct variation. They're going to give you a chart with a data set there, but before we're ready to actually tell the difference between these, we need to look at our direct variation equation, which was y equals k times x, and our inverse variation equation, which was y equals k divided by x. And the key for this is, when we're dealing with these, we want to be looking at, hey, what is our constant of variation? We're basically going to be looking at a data set and using that data set to figure out what the constant of variation is. So since I need to know what the constant of variation is, I'm going to solve our equation here, y equals k times x, for k. So I'm going to divide both sides by x, and that tells me that y divided by x gives me my k. Okay? So when I'm looking at direct variation, your constant of variation is going to be found by taking your y value divided by your x value. So that is the key. This last equation right here is the key for using that to figure out if this chart represents direct or inverse. Okay? Next, I'm going to do the same thing for my inverse. I want to know what k is. So if I get k by itself, I'm going to have to multiply x on both sides. And that tells me that xy is going to equal my k. So again, that's the key. If I can find a constant of variation by multiplying my x and y variables together, then that means that is an inverse variation problem. So for this up here, the first thing you guys are going to do is you're going to draw yourself two more rows. You got to draw two more rows. So I have in this row here x times y. So x times y represents my inverse variation. I can see that right there. The constant of variation for xy is going to give me my k there. Direct variation is going to be y divided by x, because your constant of variation is going to be found by taking your y value divided by x. And basically what we're going to do now is we're just going to fill in each of these cells. So this cell right here is x times y. So I've got 3 times 6. What is 3 times 6? That would be 18. My next one, I've got 4 times 8. 4 times 8 will be 32. 5 times 10, 50. 6 times 12, 72. So based on this column here, I can see that this is not inverse variation because there is no constant value there. So we can tell based on this here, that is not an inverse variation problem because there is no constant value. My direct variation is going to be y divided by x. So I'm going to take 6 divided by 3, which is 2. 8 divided by 4, which is 2. 10 divided by 5, which is 2. 12 divided by 6, which is 2. So notice here we do have a constant value. And since we have that constant value, I can confidently say that this data set of x and y up here represents direct variation. And not only does it represent direct variation, but I can also tell you that your k value for this equals 2. Okay, so this example up here, we've got direct variation, and we know that our k value equals 2. Okay, I can move on to another example here. We're going to use the same thing on this next example. Okay, you've got your chart. The first thing you want to do, draw 2 more rows. Okay, so we're going to do another example here. I've got x times y. So again, x times y, that's how we find if it's an inverse variation. Y divided by x is how we find if it's a direct variation. Okay, so for my inverse, x times y, I'm going to go 1 times 3. 1 times 3 is 3. 2 times 1.5. 2 times 1.5 is 3. 3 times 1, 3. 4 times 7.5, or 0.75, 3. So based on this, look, I got constant numbers. So since I have 3 constant numbers, that tells me that this data set represents inverse variation. And we can also tell that our k value for this inverse variation would be 3. Okay, so there's the 2 examples. Do you need to go through and do your direct variation? You don't need to. I mean, we already know at this point that it's inverse and it can't be both because they're opposites of each other. Okay, so we got 2 more examples here that I want you guys to try. Go ahead and pause the video and try these examples on your own. Just remember, first thing you do, set up your 2 rows. Okay, hopefully you guys have tried those on your own. Okay, going through. We're just going to draw 2 more rows. Remember, I'm going to look at x times y, and x times y represents my inverse. I'm going to look at y divided by x. Y divided by x represents your variation. So first one, -9 times -2. That is going to give me a positive 18. So my inverse variation, I'm multiplying x times y, positive 18. 36 times 8. I don't feel like that is going to equal 18. It equals 288. 45 times 10, 450. 20 times 90, 1800. So is this an inverse variation problem? No, that is not an inverse variation problem. Okay, so the next one that I do, direct variation, y divided by x. -9 divided by -2 gives me 4.5. 36 divided by 8 gives me 4.5. 45 divided by 10 gives me 4.5. 90 divided by 20 gives me 4.5. These rows all match up, so that tells me that this is an example of direct variation, and its k value is 4.5. One more to do. I got 1, 2, 2, 6, 3, 8, 4, 10. Draw my 2 rows. Okay, we got xy, and xy represents our inverse. We've got y divided by x. That represents our direct. So starting out with multiplying, 1 times 2 is 2. 2 times 6 is 12. 8 times 3 is 24. 4 times 10 is 40. That is not an inverse variation. Okay, is that enough? Can we stop and just assume it's direct? No, you cannot. 2 divided by 1 gives me 2. 6 divided by 2 gives me 3. 8 divided by 3 gives me 2.6 repeating. 10 divided by 4, geez, I picked some tough ones, gives me 2.5. So is this a direct variation? No. So the answer to this one is, this one has no variation. Okay, so again, I'm looking at this row. These do not match up. It is not inverse. These do not match up. It is not variation. So this is an example where there is no variation for your problem. And that is it on the variation.